All right, next we're going to look at a slightly different version of maximizing the area of a enclosed by a fence. Now we're going to add cost to the function. Suppose that we have a rectangular area of 20,000 feet squared that we're going to put a fence around. And the fencing material has a different cost for the north and south facing versus the east and west facing. We want to know the cost of the least expensive fence. So I'm again going to draw a picture. This is going to be a rectangle. I'm going to give the north and south sides X and the east and west sides 5. The north and south costs $250. The east and west sides cost $3.20. So the cost function for the fence deals with perimeter. So the cost will be the price per foot times number of feet. So we will have 2x times 250 plus 2y times 320. That must equal the cost. Next, we're going to look at the area. We want to maximize, we don't maximize the area, we just know that the area is 20,000 feet squared. So x times y must equal 20,000 square feet. So y will be 20,000 divided by x. This value for y I'm going to plug in here in the cost function. So the cost will be 5x plus, now this is going to be 2 times $3.20 times 20,000, which is plus 128,000 over x. All right, so now we finally have a cost function. This cost function has one variable in it. This makes life kind of nice. To find the derivative, we will use the power rule. And here, the variable x is really x to the negative 1. So that will change the sign from positive to negative. And subtract 1 from x to the negative 1 to get x to the negative 2. So 1 over x squared. Now we need to maximize this. So we'll set it equal to 0. So we have two terms. We have the 5 on one side, and then we have the 128,000 over x squared on the other. That will be 5x squared equals 128,000. My hope is that we get a nice number. If not, not a huge deal. Yes, we do. Now, normally when we take the square root of both sides here, we will take a positive and a negative root, but we're dealing with dimensions of a rectangular fence. We're only going to take the positive numbers here. So x will be 160 feet. Now, let's go back to the question and make sure we're answering it. Find the cost of the least expensive fence. So the cost function is this guy right here. Now that we know that when x is 160 feet, we will minimize here. Then we can actually figure out what that minimum cost is. So, cost will be 5 times 160 plus 128,000 divided by 160. That gives us $1,600. Now, from a technical standpoint, we probably should do things like second derivative to see whether we are concave up or concave down, but the reality of these problems, we're not really going to have any instances where we have a function that might have a maximum and a minimum to be able to figure out which one we actually need to use. So for the most part, we can assume right now that when we find the first derivative, that will be the absolute extreme point.